So let's take a look at another one of these problems from today's worksheet. I'm going to look at problem number 5. In problem number 5, we want to find out which one of these compounds completes the following sequence. So we're going to look at the different types of reaction conditions that we have. In the first step, we're doing an ozonolysis, which we know is going to cleave double bonds to give us carbonyls. And in the second step, we're treating this with sodium methoxide and methanol and some heat. We've been using sodium methoxide to form enolates. If we make these enolates, it may allow us to do aldol type chemistry. So, and what we have is we have an alpha-beta unsaturated carbonyl, which could be the result of an intramolecular aldol condensation. If we try to disconnect that, if this is where we're doing the elimination, that means that this beta position here could be where an aldehyde once was, and this alpha position here could be where the enolate was at. So that would give us something that would look like this to start off with. Now we can get to this type of a molecule if we look at our possibilities, A, B, C, and D. D, if we cleave this, will get us right to the compound that we want. If we have C, this is going to give us too many carbonyls to deal with. B is actually the product of this sequence that we're looking at. But let's take a closer look at what's happening in this sequence so we can try to understand how D is leading to the product that we want. So we're starting off with this alkene, and we're going to do an ozonolysis reaction. So first step, we're using ozone. The second step, we're doing some kind of a reductive workup. And we know that when we do the ozonolysis, we are going to cleave these carbon-carbon double bonds and replace those with 2 different carbon-oxygen double bonds. So in this case, we're going to get a carbonyl here, and we're going to get a carbonyl here. We try to number our carbons, we can make sure that we have the right numbers. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's the result of the ozonolysis step. Now let's take a look at how we're going to do this intramolecular aldol condensation. If we take this compound, we treat this with sodium methoxide, there are several different places that we can form an enolate. We can form an enolate on carbon 1, carbon 3, or carbon 5. The problem with carbon 3 or carbon 5 is that enolate, if it tries to do an intramolecular cyclization, is going to form a 4-membered ring. So 5 cyclizing down on 2 or 3 cyclizing down on 6 is going to create a 4-membered ring, which is not favorable. In the case of carbon number 1, this can cyclize down on carbon 6 and make a nice 6-membered ring. So let's take a look at what this mechanism looks like from start to finish. 1, 2, 3, 4, 5, 6. Here's my H. Take my methoxide. This is going to pull off my alpha proton and form my enolate. Again, there's a couple different ways we can draw an enolate. I prefer to do this. The other resonance structure that many people like to use is the one that has the lone pair on the carbon. Now that enolate is going to do an intramolecular aldol, so it's going to attack the aldehyde in an intramolecular fashion. This is going to form our 6-membered ring. This is my carbonyl. This is 1, 2, 3, 4, 5, 6. Carbon 6 is where we're going to have our alkoxide and an H. To complete the aldol, we need to protonate this. We will use some methanol to do that. So this is the aldol product. In the presence of heat, we are heating this reaction up. we can promote an elimination to form an alpha-beta unsaturated carbonyl. So our base, which in this case is methoxide, is going to pull off that alpha hydrogen, form the unsaturation, and kick off hydroxide. Now we always say hydroxide is a horrible leaving group, but the reason it works in this case is because we're forming an alpha-beta unsaturated carbonyl. This is a conjugated system. So the formation of that conjugated system is really the driving force for what we just did. So that's our product. We start off with this alkene. We can ozonize this to make a dicarbonyl compound. And now we can go through an intramolecular aldol condensation to get to our alpha-beta unsaturated carbonyl. Hopefully this mechanism helps you understand a little bit of how we can do this type of a transformation.